Hello, this is Mr. Mac. This is the concept video on logarithms and log functions, Chapter 8, Section 3. Okay, first of all, let's start out by actually stating a definition. We're going to define log base b of x equals y if and only if, that's what this means, if and only if b to the y equals x. Now this is our basic definition of logarithms. And let's just talk for a minute here about a couple of things. First of all, we read this log base b of x equals y. So when you see that, for example, if you have log and then a 5 down here and a 7 there, you would read this log base 5 of 7. Okay. Now, it's important to realize that the base number, the b down here, looks like a subscript on the g. You have to be careful how you write this. So when you have a logarithm, if you're writing a base, make sure that it's a subscript, and then the argument of the log, this x right here, is on the same level and size and everything as the letters log. Please work on that. Don't let that get confusing or out of whack, because if you do, then what's going to happen is I won't understand, and a lot of times when I don't understand, I mark things wrong. Woo. Okay, now what does this mean? Well, first of all, we would consider this equation right here to be the logarithmic equation, and this equation right here is the exponential equation, and the if and only if means they are equivalent. In other words, whenever this first equation right here is true, this second one must be true. If the first one is false, the second one has to be false. Whenever the second one is true, the first one has to be true. Whenever the second one is false, the first one has to be false. They are if and only if. They are logically equivalent. Now, let's take a look at this definition to some extent and see if we can't see some meaning from this. First of all, look at the exponential equation right here. And the question that I would ask you is, what is y? Pause for a moment. And you said y is the exponent. And I say to you, very good. Now look at the first equation. What is y in the first equation? Well, in the first equation, y is the log base b of x. So the first piece of understanding that you need to get from logarithms is that a log is an exponent. You need to realize anytime you're taking the log of something, what you are getting is an exponent. A logarithm is an exponent. Now, and you might want to chant that a couple of times yourself. When I used to do instruction in class, I made everybody say it out loud. A log is an exponent. I don't want to get boring here or anything like that, but seriously, guys, a logarithm is an exponent. All right, now let's go a little bit deeper. We know now that whenever you see the word log, we're actually talking about an exponent. But now, let's take a look again at this exponential equation right here and ask ourselves, what is y's claim to fame? Look at y here for just a minute. What is true of this exponent y? Pause again. You can pause the tape if you want longer. Here we go. Y is the exponent that when you put it on b, when you use it as an exponent on b, you get x. okay? So y is, we're looking over here again at the this one. Y is the exponent that when you use it on b gives you x. Now, look over here. Look over here with me at this first equation. Remember, y is the exponent on b that gives x. So y is, now remember we said a logarithm is an exponent. The exponent on b that gives x. So from the definition, you should be able to write or say to yourself, in other words, if you have log base b of x, you could say the exponent, that's what a log is, of b that gives x. Let's take a look and see if I can give you an example of this. How about this one? Now, you would say log base 2 of 8, but now if you used the pattern that I just showed you, you could restate it to yourself, the exponent of 2 that gives 8. Now pause for a second and ask yourself, what exponent would you put on 2 to get 8? I hope at this particular point you said, why, Mr. McFarland? I would use 3, because 2 to the third is equal to x. Now watch this. By the definition, log base 2 of 8 equals 3 if and only if 2 to the third equals 8. And it does. And that's what we're saying with this definition of logs. So a logarithm is an exponent, and even further than that, it is the exponent, the word log, say exponent of, and say the base, b, that gives, say the argument, x, okay? The exponent of b that gives x. Our example here, the exponent of 2 that gives 8. Okay, now, one of the things it is very important for you to be able to do is to be able to take these two equations, and if you have one, write the other one. Now, a couple of things that I noticed when I was a student here was that the base of the logarithm ended up also being the base of the exponential function. And the argument of, and remember, the log is an exponent, so the thing that you get is going to be the exponent of the exponential function. And then, of course, the 8 goes in the other spot. So you should practice that some, and some of the exercises will also have you practice that. But you need to be able to write something that's in exponential form, in logarithmic form, or if you're given it in logarithmic form, you need to be able to write it in exponential form. And sometimes that will be what's required to solve the problem, just changing it from one to another. All right, now, the next thing we would like to look at is the graph of log functions. So let's talk about a specific example. Let's do f of x is equal to log base b of x. Okay, no, let's not use b. Let's use a particular base here. F of x is equal to log base 2 of x, and we want to take a look at this particular graph. All right, first of all, another name for f of x is y. So we're going to write y is equal to log base 2 of x. And we don't really know a whole lot about this function, but one of the things that we could do is we could plot, we could pick values of x and find out what y is and plot them. So let's do this. We know that this is true if and only if 2 to the y equals x. Now, in this case, let's pick some y's rather than x's, and when we pick a y, we'll find out what x is. So, first of all, let's pick 0 for y. If we have y is 0, 2 to the 0 is 1, so x would be 1. Now, let's pick 1 for y. 2 to the 1 is 2, so x would be 2. Let's pick negative 1 for y. 2 to the negative 1, that's 1 over 2 to the 1, or 1/2. So we have these 3 points. Now let's take a look at these 3 points. We have 1, 0. We have 2, 1. And we have 1/2, negative 1. Now, it turns out that if we were to plot more points, that the graph ends up looking something like this. It asymptotes with the y-axis down there, and it goes off over this way, although it does get pretty slanted after a while. Now, one of the things that I'll point out is if we had the graph y equals 2 to the x, we would have the point 0, 1, 1, 2, and negative 1, 1/2, and this would be the graph of the exponential function y is equal to 2 to the x. Now, if you take a look at these two graphs on the same axis, notice that the blue graph is the reflection of the red graph over the line y is equal to x. What that means is that the log base 2 of x is the inverse function of the exponential function 2 to the x, because they're reflections of each other over the line y is equal to x. So the logarithm function is an inverse function to an exponential function. Now, it is kind of important to realize that when you have a logarithmic function, the graph is going to look like an exponential function, but it's going to be reflected over the line y is equal to x. There turn to be 3 points that are important for you to find, and then after that you can pretty much find where the graph is. You can find a few more points if you want. One of them would be the point 1 over b negative 1, where b is the base. Another of the points would be the point 1, 0, and the third one would be the point b 1. And let's just take a look at that. If we have log base b of x equals y, let's take a look at 1 over b. Log base b of 1 over b equals y. Now remember, y is the exponent. So we would say the exponent you'd put on b to get 1 over b. Now, what exponent would you put on b to get 1 over b? Well, 1 over b is the reciprocal of b, and the way we do that is we would use an exponent of negative 1. So y would be negative 1. So when the input is 1 over b, the output is negative 1. Or the exponent on b that gives you 1 over b is negative 1. So 1 over b negative 1 is one of the 3 points that you'll find on a logarithm graph. Now, also, let's take a look at the second point. If we were to put 1 in, we have log base b of 1 equals y. Now, if we read this the way I showed you a little bit earlier, what exponent would you put on b to get 1? Well, anything to the 0 power is 1, so y would be 0 at that particular point, right? So we get the point 1, 0, and that's going to be on the logarithm graph as well. Now, the third point that is gives you a good idea. Oops, I shouldn't have grabbed that. Let's just get that part back. I just want to get rid of this part here. The third point we want to talk about is what about the point, what about when we put b in for x? If we have log base b of b equals y, now, what exponent would you put on b to get b? Well, obviously, b to the 1 is b, so y would be 1. So we also have the point b1, b comma 1 on the graph. And then notice we have an asymptote with the x-axis, and it takes off like that. So you're going to have to do some graphs. Now, there's a couple of things you can do. One of the things you can do when doing a logarithmic graph graph is to find these 3 points, 1 over b, -1, 1, 0, and b1, and take it from there. The other thing you can do is you can use the definition of logarithms to write your equation, if they give it to you in logarithmic form, in exponential form, and then pick values of y, find out what x is, plot those points, and connect them with a smooth curve. Those are the 2 ways that I'll be doing these graphs in the solution videos. Now, one more thing here. We are now going to make the log function a parent function. And so let's take a look at this. F of x is equal to a times the log base b of x minus h plus k. Now, once again, this x minus h is a left-right shift. See, what we're doing is we're subtracting h from x before we perform the function, and that affects the function by shifting the graph either to the left or the right. If it's x minus 2, we would go 2 to the right. If it's x plus 3, that would shift the whole graph 3 to the left, okay? So the number that's added or subtracted to x before we perform the logarithm is a left-right shift. Now, the a is the vertical stretch. Now, if the function would ordinarily say that the point that you put something in for x and the point you get out is like, say, q, then the actual point would be a times q. This a right here stretches the graph vertically if it's bigger than 1, or if it's between 0 and 1, it makes it, it compresses it. Also, if there's a negative sign on this a, then what happens is the graph is flipped over the x-axis. So a is going to be the vertical stretch. And then finally, the plus k is the vertical shift. And this one happens in the direction you would expect. In other words, if it's plus 2, then everything's shifted up 2. If it's minus 3, everything is shifted down 3. So on the transformations, once we've kind of handled the log base b of a part, the minus h is going to shift it left to right, the plus k is going to shift it up and down, and we'll do some of those in the solution videos also. Okay, so that pretty much takes care of the concepts needed for Chapter 8, Section 3. It is very, very important that you do these exercises as well. And we're done.